everyone, it's Justin again. In this lesson, we're going to be going over how to find the area of triangles and rectangles. This is a topic that you might have learned previously, but it is going to be the foundation for the entire rest of this unit, so it's important to make sure that you're really confident in your knowledge on this before we move on. By the end of this lesson, you will be able to use area formulas to find the area or side lengths of rectangles and triangles. First, we're going to discuss the area formula for rectangles, then we'll talk about the area formula for triangles, and finally, we'll complete 2 example problems. Let's talk about the area of rectangles first. As a reminder, area represents the total 2-dimensional space inside of a figure. In this rectangle, that would be all of this green space. Chances are that when you originally learned about the area of rectangles, you learned the formula area equals length times width, or maybe capital A equals L times W. In this case, the length and width are the 2 side lengths in this rectangle. Now, there is absolutely nothing incorrect with this formula. However, we can improve it. Length and width are dimensions that only apply to rectangles. There are many shapes other than rectangles that exist. Let's talk about some new terms that can help us apply them to more polygons. Instead of length times width, a better way to write this formula is as base times height, or B times H. In a rectangle, the base can be any of the 4 sides. Let's just use this one. The height is then the perpendicular distance from your base to the opposite side. And since all sides in rectangles are perpendicular, this height is the same as the length of this side. So, this formula is exactly the same as your trusty old length times width, just with updated vocabulary that we can apply to a wider range of polygons. Speaking of applying those new terms to other polygons, let's talk about triangles. The formula for finding the area of a triangle is 1/2 base times height. This formula probably looks familiar to you, but let's look into what it means. Just like in a rectangle, the base refers to any side of the triangle. The height refers to the perpendicular distance between the base and the opposite vertex. Let's see what that looks like for each of the sides in this triangle. I have 3 options for which side I choose to be my base. If I use this bottom side as the base, then this line represents the height. If I choose to use the right side as the base, then this line would represent the height. Lastly, if I chose to use the left side as the base, then this line would represent the height. What's important for you to see here is that there is no right or wrong side to label as the base. Just make sure that you're using your height correctly. You might recognize these heights from back in our triangles unit. Another term for these lines is altitudes. If you think back to your triangles unit, you might remember that the location of an altitude, or height, is different depending on the triangle's angles. These triangles that we've been looking at so far are acute triangles, and their heights will always be inside the triangle. But in a right triangle, if you use one leg as your base, then the other leg will be your height, because the legs are perpendicular. In an obtuse triangle, it's even possible for your height to be outside of the triangle. Make sure you're always looking for that perpendicular segments to the opposite vertex. Now let's put some of this information into action. Our first example problem says that the area of the rectangle below is 42.92 centimeters squared. What is the value of x? We've been given one side length of our rectangle, and the other side length is x. Since we're dealing with the area of a rectangle, we're going to be using the formula area equals base times height. We have 3 pieces that we can substitute into this equation: 42.92, 11.6, and x. Where do you think 42.92 should go in my formula? 42.92 is the area, so it should go into my formula for A. Now where should 11.6 go? 11.6 can either be the base or the height in my formula. It doesn't actually matter which one. I'm going to be using it for the base. That just leaves us with x for the height of the rectangle. Does it seem correct that x is the height? Yes. Since x is the other side length of the rectangle, it's the perpendicular distance between the base and the opposite side. Now we have an equation that we can use. Pause the video here and solve for x now. You should have divided both sides by 11.6 to get a final answer of x equals 3.7. Since the side length in the rectangle was presented as x centimeters, we don't need to add a units label to our answer for x, so let's leave it like it is. Let's do one more together. Our second example problem tells us to find the area of triangle MNP. We've been given a few lengths within our triangle as well. Since we're dealing with the area of a triangle, we should start by considering our formula. 1/2 base times height. Well, we have options in a triangle. Which side of this triangle do you think we should be using as our base? MP is the best side to use as the base here, because if MP is the base, which segment will be the height? Yep, if MP is the base, then LN is the height. And we actually have segment LN in our drawing. We know that LN would be the height from MP because they're perpendicular, and LN goes to the opposite vertex. The problem is, we don't have any given information for the length of LN. Do you have any ideas for how we can find its length? Well, we have a right triangle with two known side lengths. Oh, we can use the Pythagorean theorem to solve for the unknown here. Pause the video now and use the Pythagorean theorem to solve for the length of LN. Did you fill in 5 and our unknown length for A and B, and then 5√5 for C? If you got stuck before here, pause the video again and try to solve it now that you have an equation. To solve, I'm going to simplify, isolate x squared, and take the square root of both sides. Now I can see that the length of LN is 10 yards. If you need a refresher on how to square roots like 5√5, ask an adult to check out the answer key for this problem in the Notes template PDF. Now let's go back to our area formula. We know that the height is 10. We want to use MP as our base, so what's the length of MP? By segment addition, we know that the length of MP will be 11, because we add 5 and 6 together. What will this give us as a final answer for the area of the triangle? 1/2 times 11 times 10 makes 55. Be careful. What should our units be? The units for the lengths within the triangle are yards, so the area should be square yards. With our units, we now have our final answer. Now you can use area formulas to find the area or side lengths of rectangles and triangles. Here are a few tips to help you during your practice. First, make sure that your base and your height are always perpendicular. And be careful about the units for your final answer. Length is units, and area is units squared. You can explore these units further in your Notes template PDF. There's also one more additional practice problem in there for you to work on before moving on to the practice. Good luck, and I'll see you next time. Hey.